kind of a tricky one, so I'm going to go extra slow. I'm going to be asking you lots of questions, and I want you to raise your hand, hair trigger, if you're starting to feel lost. What we're going to do is go through the slides, and then we're going to do some live coding to kind of go over the material being presented on the slides. So that said, let's get started. So the things we're going to cover in this lesson on pass by value, pass by reference are primitive versus complex types, variable assignment, passing values into functions, equality operators and pass by value, pass by reference, and then finally arrays and the dot slice method of arrays. So how many of you guys remember the difference between primitive values and complex values? Anybody? So you're familiar with the term primitive value versus complex value? No? Okay, sorry. I thought it was covered in the pre-work. So that's fine. We'll cover it real quick. Basically, in JavaScript, values have types. There are two types in the whole JavaScript language, primitives and complex. The primitive values you can see here, they're strings, numbers, booleans, undefined, null, ES6 symbols. Don't worry about the last three for now. We're going to focus mostly on the first three in terms of what we're doing today. Complex values in JavaScript are all objects, including arrays, and functions. And just to illustrate one difference between how primitives and complex values can function, I got this very quick example. On line 1, there's string foo, which is given the value foo as a string. In line 2, there's array foo. Yeah. What? Zoom in. Yes, yes, of course. How's that? Is that good? Yeah? Cool. On line 2, there's array foo, which is an array, which is to say an object, which is to say a complex value. Now, you might remember, if we run this, good. You might remember that in both cases, hold on, string foo, we can use bracket notation to access indices, right? That's how these are similar. But they're very different in how we can mutate or not mutate these values in JavaScript. For example, if we do array foo 0 equals B, what do you think will happen if I type array foo now? What do you think will be returned? I heard someone say something very quietly. Does that person want to say it a little louder? It sounded right. Yeah? Let's check. Hey, it will indeed be BOO. Now, what happens if we do the same thing with string foo? I think you see where I'm going with this. It's not going to work? Right. Do you know why it won't work?
The strings are immutable.
Yeah, exactly. So all primitives are immutable. So let me go back to the thing here. Where did I put it? I put it here. Strings, numbers, booleans, and all the rest of these are immutable, unlike complex values, which are. So strings are primitive values, like we said. So what does that mean in terms, oops, giving the game away a little bit. What does that mean in terms of how these values are manipulated and assigned? In this instance, we've got two variables declared, a British city variable and an American city variable. The American city variable is set to the value of the British city. And then on line 5, manipulated. We add the string new to American city. So if we were to console, like what do you think is going to appear for the values on line 7 and line 8?
York and New York.
Right. York and New York. What's important to understand here is that on line 3, when we assigned brief aside, do you guys remember talking about the difference between variable declaration and variable definition? Give me a yes or a no. A little bit? It's super easy, so I'll go over it again. The let British city, let American city, this is declaration. We are declaring a variable exists. But until we have this equals sign, both of these variables are undefined. It's the equals sign that gives us the definition of what that variable is. So in this case, we're defining British city to be the string York, and we're defining American city to be a copy of the value assigned to British city. So American city is York too, but it's not the same York. It's just a copy of the primitive value that we assigned to York. Which is why when we change American city, we like British city isn't touched at all. It's in a totally separate room from whatever we're doing to American city. And yeah, to go into some live coding demonstration, let's say we've got Harry's age being 16 and Hermione's age being Harry's age. So before we manipulate anything, someone confirm for me what Hermione, like if I were to run this and then type Hermione's age, I would get what? Exactly. But let's say Hermione's birthday happens. Now, what's Hermione's age going to be? 17. Right. And Harry's age? Oh my God. Oh. Surprise. Yes, you still need to spell things correctly. It's 16. This happens because our reference to what Hermione's age is has nothing to do with Harry's age after we've copied it. We only touch that once and then we never touch it again. Going back to the slides. So now let's talk about complex values. Arrays are complex values. So like the previous slide, on line 2 and line 3, we're declaring two variables, British city and American city. In this case, the definition of British city is an array with the value, the string York. But the value of British city is an array. Does that make sense? So now, when we set American city when we define American city to the definition of British city, we are not, this is sort of like the keystone of everything else we're going to talk about the rest of the lesson. We are not making a copy of the array with York in it. We are instead making a copy of the reference to, let me back up a little bit. Actually, oh, here's a whiteboard. Okay, great. I'm going to go to the whiteboard for a second, just to make this as explicit as possible. When we have British city, is this good? Sorry, can everyone see this? Really small? Great. When we have let British city, what is happening is that there's like some memory in the computer. We call this memory address 0x111. That is being told, okay, we now have a variable called British city. And if the definition of, if the value of British city was a string, then at this address, 0x111, we would also store a string, whatever. But because objects are much more complicated than primitive types, like they're just more memory intensive, we're not storing the object at the address of this thing. What we're doing instead is storing a reference to somewhere else in the computer. Because it's at this other place in the computer that we have an object. So what that means is that when we have another thing, American city, and allocate memory for it, American city, like before, we're declaring a variable. We're saying this is like, you know, OX333, but we're not making a copy of what's being stored here, because there's nothing, the only thing being stored here is a reference. What we're doing instead is we're going here, we're saying, oh, okay, at OX111, we see a pointer to this object. It is the exact same object, which means that when we manipulate this object, we are manipulating it for all variables that have a reference to it. We're manipulating it for, we're changing the object, and everything that is like pointing at the object, it like gets changed as well. We'll see this in live code in a second. Actually, we'll see it in live code right now. Let's go to live code. So we'll comment this out. We'll say we have Harry's school and it's an object. Key value pair, the key is school, the value is a string called Hogwarts. Hermione's school is imagine Hermione's school being American City here. It is pointing to the same object that Harry's school is pointing to. That means if we were to do something like mutate the object that these things are pointing to, then Hermione's school, yeah, she turned it pink. Can't stop Hermione. Hermione's school is now pink Hogwarts, but because the entire object, like the one object that all things are referencing was mutated, Harry's school is pink Hogwarts as well. So to go back to the slides, when you can see on line 5, we are mutating the value, we are mutating what the object that British and American City are pointing to. So now when we console log British City and American City, even though theoretically it looks like we've only changed American City, we've changed both. Does anyone want me to code out some more examples about this? Or are we good to continue? One more example? Absolutely. So let's say, yeah. Let's say I've got var sam equals is very cool. Yeah, I heard that. And let's say, I was going to use your name, but your name is also Sam. Let's say Tatir. Yeah? Okay, great. Let's say Tatir is set equal to Sam. What would, if I console log Tatir, what would I get? Is very cool. Right. Let's say we modify, right? Because this is a complex value type, we can change it in a way that we couldn't if it was a string or a number or a bool, or any primitive type. So now we're going to add something to this array, the Tatir array. We're going to say really. So now the Tatir array should be Sam is very cool, really, right? But because the Sam array and the Tatir array, or sorry, let me put it this way. Var Sam and var Tatir are both just pointing somewhere, right? They, in and of themselves, do not have anything like attached to them, right? If you think about Sam age being 28, like that is my age, right? Like it is, there is an idea 28 and it is given to Sam. like it is inexorably linked to that variable declaration. But in this case, line 11, 12, all this stuff, what we're doing is just assigning variables, like we're creating labels that allow us to reference somewhere else in the computer's memory. Does that make more sense? Yeah? Cool. All right, we'll keep it moving. Yeah. Why do primitive values and complex values behave differently? You'll be able to answer that at the end of the lesson. We hope. If not, no worries. We're here to help. So yeah, let's talk about assignment. I sort of already went over this, but rote repetition has its place in computer science. So we'll repeat. When you assign a primitive value to a variable, that variable stores a copy of that value. So like I said before, using that equals operator is our keyword, is the word representing assignment. So we're saying variable first is assigned a copy of the value 20. We can reassign it by using the equal sign again. Now first equals 30. If second equals 30, it is not the same 30, right? They're both the number 30. They both can do the same things. But in as much as we're manipulating a machine and everything we do is stored somewhere in bits and bytes in that machine, the two 30s are different. Which means if we increment the second, we do not affect the first. Yeah. This is stuff that we already did in live coding, but I'll go through it one more time anyway. I don't know why I'm looking there. Yeah. So first equals 20, second equals first. Incrementing, like on line 2, what we're doing is we're just looking at what is stored in the memory location first, making a copy of its value, and assigning it to the memory location second. So yeah, the most important thing to remember, I think, is that, the most important thing to remember is that with primitive values, you're making a copy. With complex values, you're not making a copy. You're instead pointing to the exact same place. So, which means modifying the object in one place will modify that object for everything else. Covered this already. Yeah. Covered this already. Okay, let's talk about slice. So how many of you guys remember what slice does or what it's supposed to do? Does anyone want to give me like a quick synopsis of when we used slice before?
It returns like a section of a string.
So yeah, this is what can be tricky about like learning the dot slice in JavaScript, because there's a string dot slice and there's an array dot slice. And you're totally right. It does return, like the dot slice method, it's a function, and it takes parameters, and those parameters determine like what gets returned. What's important we're going to talk about slice in the context of array dot slice, and specifically, we're going to talk about it in terms of what you said about it making a new copy, right? Because there are times when we want to capture the values of an object and mess around with them, but not modify that object itself. That's where slice really performs well. So for example, var, you know what, I didn't even need to erase that stuff. Just keep it. Let's say we've got, right now on line 12 and line 13, we've got two variables that are pointing to the same object. But if we wanted to have two variables that seem equal but are not, what we would do is we would set the value of tatir to sam.slice and not give it any arguments at all. What this does is make a copy. meaning that when we modify Tatir, push cooler than Sam. Sam is still just very cool, but Tatir is cooler than Sam. Do you guys want to see another example? Yeah? Okay. So let's say var nums1, running out of ideas. So these seem equal, right? When we look at them, what we see is an array with 5 indices, and there are primitive values that are identical at each indice. But the whole concept of primitive values versus complex values means that even though what we see, like from our perspective, these are equal, from the computer's perspective, they are not. Because when we define an object, which is what we're doing here, because arrays are objects. So when we define an array, or when we define a function, or when we define an object literal, which is what it's called when you have those curly braces, we are creating something new in the computer. So you guys have used triple equals before, right? Yeah? That said, what do you think is going to happen here? False. All right, I'm going to ask you a tricky open-ended question. Can you think of any way, like what we would need to do to make nums1 equal nums2? Yeah, no. So that would determine whether or not all the values in each of them are equal. But if I wanted to, like, if I just wanted to modify what's happening, if I wanted to modify the definition of what's happening here and have 15 return true.
You just have it put into a string instead of.
That's another idea. I think you guys. Oh, well, one more.
Set nums1 equals nums2.
Why do you think that was the case?
Well, because if it's stored in a different part of the computer, like a different piece on its own, it wouldn't even check to see if it's 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. It could just check that they're both pointing to the same data.
Yeah.
And know it must be the same.
Yeah. Because what? Gone?
What would it be if it was var nums2 equals slice, the entire slice of nums1?
Sorry, repeat that, please.
What if you did variable nums2 equals slice of nums1, like the entire thing?
Nums2.
What if you define it as that?
Oh yeah. If I did this, is this what you're talking about?
Yeah.
What do you think would happen? Let me put it this way. What's the difference between nums1 dot what's the difference between nums1 dot slice and this? It's a trick question. There is no difference. They're the same thing. So if we do this, it's going to return false again, right? Sorry, remind me your name. We did the name game and I forgot it. My man in the front. Yeah.
Oh, Andrew.
Andrew, of course. Andrew? No.
No, I was the other.
Awesome, Andrew. Sorry, forgive me. Very not awesome of me. Yeah, your explanation was dead on, and what you asked me to do is an elaboration on that. Because what we're doing here, when we set nums1 equal or nums2 equal to num1, what we're saying is this equal to itself? It is. You guys, yeah,
So it's like nums1 and nums2 are pointing to the same like reference, but they're pointing to the same address.
absolutely. Yeah.
Sort of like primitive values, primitive variable together automatically makes the copy.
Repeat that, please.
Like automatic primitive values, when you're setting the variables to like each other, automatically makes the copy for you.
Yeah.
Versus this saying, actually you're just going to point to this value because that's the value that.
Right, right. That dot slice function is a way to kind of do what we're doing when we assign, if we were to assign nums1 34 and nums2 34. It's not the same 34 in the computer, but it's the same idea of 34, right? Does that sound a little too like philosophical? Because that's what it is. Sorry, Con.
Well, so it doesn't actually check when it's doing two complex things and it's equating like equals to each other. It's not actually checking the values at all. It's just checking to see if they point to the same spot.
I actually do not know. I don't know what is happening in machine code with equals.
Right.
What I can tell you is that what equals does is when you apply it to objects, is it checks the reference, not just the value. Yeah.
But if you only did a double equal sign, because isn't that no longer comparing the equal sign? Isn't there a difference between a double equal sign and a triple equal sign?
There is.
So if you did a double equal sign, we'll do the same thing. It's still just pointing to the reference. So.
Double equal sign in this, so a double equal sign is kind of frowned upon by like real JavaScript developers or even real developers in the first place. What double equal sign does is it checks value but not type. So what double equal sign does is say that 1 a string and 1 an integer is true, right? But if we were to do, so let's just make it easy on ourselves. It's still going to be false because like the double equal sign isn't really pertinent to comparing complex value types. Good question, though. Shall we continue moving forward? Cool. Oop. Where did my thing go? Went right here. Okay, great. So we're going to go through here. Oh, sorry. So now we're going to get into passing primitive values. When we say passing, what we mean is passing into a function. So in this function on line 3, adds 20. Adds 20, by definition, takes a parameter called num. And num, in this case, is being passed a primitive value, the value 10. So what this means, I'm just going to go down line by line and go over what's happening exactly. So on line 1, we are declaring a variable called mynum, and we're defining it. We're giving it the value 10, a primitive value because it's a number. On line 3, we are declaring a function, adds 20. We're saying that it takes a parameter called num, and then inside the function, the logic that we're doing is we're adding the integer 20 to the parameter num, and then returning num. On line 8, we are declaring another variable, this time called return num, and that variable is going to be the value returned by passing the value associated with mynum into the function. It's a little complicated, so I'm going to say it one more time. The value of mynum, which is 10, is being passed into the function adds 20. And what that function returns is being assigned to the variable return num. So when we console log mynum, well, we'll get there in a second. When we console log mynum, what do you think is going to happen? What's that? 10. All right. How many of you guys agree? How many people disagree? Ghosts. What about return num? What do you think return num is going to be? What's that? The solution of the function? Give me a number. 30? You are totally right. The reason, and this is what's so cool about pass by value versus pass by reference. Because the value attached to my num is a primitive, when we use that value to do something, in this case, to return another value with the function adds 20, the value attached to my num does not change because it is only a reference by which other copies are being made. Conversely, when we pass complex values, behavior is different. On line 1, we've got my array. My array is an array with the number 10 as its only element. The function on line 3, pushes 20, takes an array, uses dot push to mutate that array, to change the value of that array, and then returns the array that it's been given. So on line 8, we have a variable called returned array, and we set it equal to pushes 20 taking my array. What do you guys think is going to be logged on line 10, and what do you guys think is going to be logged on line 11? Any idea? 10 and 20? You think that line 10 is going to be 10 and line 11 is going to be 20? How many people agree? Who thinks it's going to be something different? And if so, what?
Array of 10 and 20.
For which one?
Both, I think.
For both. How many agree with other person whose name I forgot?
Jordan.
Jordan! Oh, this is especially sad because everyone forgot your name. I won't forget again. Yeah, you agree? Yeah. They're both 10 and 20 because what we're doing here inside this function is modifying that object everywhere. So to use another example, go back to Hogwarts. Let's talk about passing primitives versus passing primitives into a function. I'm just going to cancel all this other stuff so we don't get cluttered. We have a function called aging potion, and we don't have the ages of Harry and Hermione. So let's do that. Actually, it doesn't matter. Okay. We have a function called aging potion that takes an age and then returns a modified version of that age. So when we have a variable called old Harry, that's aging potion taking Harry's age. What's line 29 going to be? What's line 30 going to be? Someone I haven't heard from, maybe?
Can you scroll back up to the ages real quick?
Yeah, sorry. There's a function. Yep.
16 and 56, or 66.
Absolutely correct. 16 and 66. Old Harry, who's taken the aging potion, is now 66 years old, but regular Harry, still 16. Conversely, if we've got, let me uncomment this stuff. Comment this in. Let's say we have an array called students that has Harry, Ron, and Hermione, and we have a function that takes two parameters, an array and a new student. We take the, and then we pass this add student function, our students array, and then a new student, Neville. I'll console log this too, just so I'm not confused. Do I console log anything here? No? Great. Okay. What do you guys think new students is going to be? And Neville? That is correct. What about students? Same thing. Because in this function, as we did with the example in the slides, we are mutating an object. So all pointers to that object are pointing to the same one thing that we mutated. All right. Let's see if there's anything else that we need to cover. Quality operator we talked about. Talked about this. Oh, okay. This is interesting though. Oops. Keep giving it away. So things can start to get funky when we have nested arrays with the slice function. So remember that what slice does is create a copy of an array, but it creates a shallow copy. So array 1 is an array that has an index that is also an array. When we create a copy of array 1, what we're doing is creating a new object, but the second, like the second index of that object still points to the same place. This is very Inception-y. I might go back to the whiteboard. Yeah, I'm gonna go back to the whiteboard. So this outer array, we can say is at memory location 0x111. But this inner array is not at 0x111. This inner array is at 0x222. So that means when we create a copy of array 1, sorry, my handwriting's so bad. Let R2 equal, of course this whiteboard is bigger, R1 slice. Now, this R2 is a new place in memory. And this, because this is a primitive, it is a new copy, but we didn't change this. This index that is an array is still pointing, you know, like R2, 1, which to us looks like this, is still pointing here. Yeah. Let's go back here. Yeah. So array 1, like this triple equal sign, it's false because the triple equals does it by reference. This doesn't. Does that like this slide isn't a great example of that. I think the next slide will show that better. But before we get there.
So if you like array 1 and then in brackets 1 equals array 2 in brackets 1, because you just be referencing the second thing, it would be equal, is what you're saying.
Yeah, you know what? Let's try it. I think so, but we'll confirm. So what you're saying is, comment all this stuff out. You're saying if we have var test equals 1, and then 1, or 2, 3, var test 2 equals 1, and then test?
Well, no, so slice,
Okay.
make a copy of it,
Yep.
and then compare, like, in the test, do test in brackets 1
Mm-hmm.
equal to test 2 in brackets 1.
And your assumption is that this is going to be true?
Well, yeah, because you said if the second stays the same.
Yeah,
Okay.
it is.
So all nested arrays will be true even if it's sliced, but everything outside of the nested array will still be false. Like when you're comparing.
The important thing to remember is that slice makes a shallow copy. A shallow, yeah, I think that's what you're saying, but like this is just language that you'll hear over and over again, shallow copy versus deep copy. It's like a whole big thing. It's actually an interview question that I got asked a couple weeks ago. Yes, dot slice makes a shallow copy. It copies that shell of stuff. But the stuff inside it, as we just saw here, if it's a complex object, it's still pointing to the same place. You would have to modify, you would have to like dot slice this index or something to create a totally new copy. Or you'd have to create a function that deep copies stuff, but we're not going to touch on that for now. Actually, I think it might be a workshop. Well, all right. Yeah, I said let's just do this one more time. It kind of goes over what we just did, but we've got array 1, we've got array 2, slice. We are pushing 4 to that array inside the outer array. And then what that does, because they're pointed to the same place, is it changes the object for both. So to recap, we covered primitive types versus complex types, what you can do in terms of modifying them directly. We covered variable assignment, what it means to use the equals sign to define a variable that's previously been declared by var letter const. We covered passing values into functions and what it means to do logic on whatever we passed into the function in terms of how we affect other variables that are the same as that are either complex and pointing to the same place or primitive and just copies. We covered equality operators, pass by value, pass by reference, and we covered arrays and slice. Are there any final questions? Does anyone have an aspect of it that they want to go over again?
Can you just hit the slide before this one?
Yeah, of course. Oops, sorry. You know what? I'll just leave this here. This is the one you're talking about?
Yeah. Wait. I think so.
Yeah. And it's false because that slice is creating a shallow copy.
Right.
So the
They're pointing to different references.
exactly. Array 1 brackets 1 and array 2 brackets 1 are the same, but array 1 is not the same as array 2. Did I see a hand that I missed? Anyone else want to go over a particular aspect? Okay. I believe now it's time for the workshops. Do you usually take a break, go to the bathroom, stuff like that? Get a drink of water? Cool. I will be walking around helping you with the workshop, and so will David and Kevin, the fellow. Sorry, should have introduced Kevin at the beginning. Kevin, stand up. That's Kevin Ho. He is extremely capable and friendly. He will also be helping with any help tickets that you have during the workshops. All right, go do your in-between thing.